Thank you very much. Good morning, everybody. We'll take the next hour to have a short introduction to some useful bash commands and usage of CVS Git. I gave you a link in the chat, so feel free to download the archive, which will be available at this URL. And there is you will find the slides if you want to follow on your own computer, and also some bash scripts that will be useful for the workshop. So feel free also to have a terminal open during the presentation to test what we are seeing. Okay, we have. I get that the presentation won't be too long, so we have lots of time to practice. So don't hesitate to interrupt me and to ask me some questions if needed. So let's start. Let's start a little bit with a first touch with the command line interface. Okay, as you can see here, you have a screen of what you will see when you open a terminal with on Linux with the bash launched. And what you can see here on the first line here is the prompt. Okay, what we will call the prompt. Sorry, it's just some kind of text that gives you some informations about your current terminal. For example, which user is logged in, the name of the machine, and also the location of the shell. We will see the location a little bit later. This prompt is very useful. It's interactive, and you will be able to execute some commands. Here you have, for example, a command called "Who am I?" If you returns you, in fact, the username of the user logged in, and you can enter some commands, press enter, and then get the results print on the standard output. Okay, when you can enter some commands, okay, you've got the prompt, and then you've got the normally it's a flashing prompt, and you can enter some commands. Okay. How do we enter some commands? In fact, the syntax is a little bit the same for all the commands. You have the name of the command, the different options that we will cover for a few of the commands that we are interested in today, and some parameters. Please be careful because bash and shell in a larger extent are case sensitive. So capital LS is not the same as LS. And the options are some kind of text beginning with the dash, which aims at modifying behavior. For example, if we take the example of a ls command, we can see that the ls gives you some list the files that are in the current directory. I can give a parameter, which is in fact a file on my computer. Let's say, and you will see that this time it will list all the files that are available in the directory /home/Mr. And we can also give some options. For example, the -a, which enables, which prints a little bit more information. It also prints the hidden file. Okay, we'll see a little bit more on that a little bit later. So syntax is always the same. You have the name of the command, and then space separated, you have the parameters and the options of the commands. Sorry, I have my daughter at home, and it's not always easy to get her focused on anything else than her dad. So let's have a little bit on the generalities. Okay, and to be sure that you correctly understand the command line interface, you should have a good understanding on how things are stored on your hard drives. Okay, I will focus on Unix and Linux-based operating systems, but it's a little bit the same for Windows-based, for example. So the file system in Unix and Linux resembles a tree structure. Okay, it's not really a total tree, but for the sake of this short introduction, we can approximate it by a tree. It should be okay. And the root of the tree structure is the slash directory. Okay, it's the root. It represents in fact your the partition on your hard drives. Okay, when you open the shell in a Unix and Linux operating system, every shell that you will open will be located somewhere in the tree. By default, are located in your personal directory. For example, here the personal directory is the personal directory is /home/Mr. Freeze. You have a star here to show you where we are located in the tree. And every command that you will launch are relative to this location. So you have few shortcuts for that may be useful for you to handle and to represent everything at the tree. These shortcuts are given here. Okay, you have the dot that you can find here, so which represent the current directory. Okay, and the double dot, which represent the parent directory. For example, if I do ls dot, it's the same as if I do ls. And if I do that, you will see everything which is contained in the parent directory. You maybe see also the tilde sign. We won't use it during this course, but you may see it. For example, you can see it usually in your prompt here. It refers to your personal directory. Okay, so the tilde expands to, for example, here /home/Mr. Freeze. And files that begins with a dot are called hidden files. Okay, so with everything like that, you should be able, in fact, to identify every file on your hard drive. Okay, and you have two ways of doing that. The first one is what we call an absolute path. Okay, you understand that sometimes files share the same name, and to distinguish themselves, we have to give the location. In fact, the whole identifier of a file is its absolute path. Okay, and it's just the location in the tree starting from the root. And you have the relative path, which is in fact the location of the file regarding starting from the current directory. As I explained you a little bit earlier, your shell is located in the tree, and the relative path is just a way to access the file from the current directory. For example, if I take the slides.pdf file in my tree directory, if I want the absolute path, then I take the slash and then home, Mr. Freeze, Puma, and then slides.pdf /home/Mr. Freeze, Puma /slides.pdf. I can also have a relative path. Since I'm located in /home/Mr. Freeze, okay, the relative path of slides.pdf is just Puma /slides.pdf. Please note that an absolute path always starts with a slash, and a relative path never start with a slash. If I take other files, for example, the ls file here, you will have the absolute path, which is /bin/ls, and the relative path, which is .. because we are here. So we need to identify the parent directory and then the parent directory again to get back to the slash directory, and then come back to the bin directory and find the ls file. Okay, that's okay for everybody. This file structure. Just to be sure, it's a very important concept in the command line interface, since it will allow you to every time you will have to identify a file, you will have to identify it by either its relative path or its absolute path. So please sure that you won't have any question on that. So let's see our first commands. So as I told you before, you are located somewhere in the tree structure, and you should be able to walk around with walk around in the tree structure, and you have some commands to do that. And one of these commands is cd. cd stands for directory, and it allows you to change the current location of your shell. Okay, you will have. You will see here this kind of syntax. I will always use the same. Okay, and when it's between this kind of brackets, then the parameter is optional. You are not you don't have to give it to the function. And if this parameter is not given, then cd change the directory to your personal location. For the exploration command, you also have the ls command that we already saw a little bit, which stands for list, okay, which lists informations on files and on every file that is given in the parameter. If no parameter is given, then it lists the current directory. And if a parameter is given, it gives you information about the files described in the parameters. And you have one useful option. There is lots of them, but I won't cover all of them, which is the -a option, which also allows to print hidden file. Okay, if you see by default, if I do an ls, let's say I will create a hidden file. If I do ls, the .hidden file that I created isn't printed, and if I do it with the ls-a, you will see here that the hidden files and also the special directory appears on the command line. And another useful command that you may be use, it's pwd, which gives you in fact the current directory in which your shell is located. For example, it gives you, in fact, the absolute path to the current working directory. Okay, so let's now be a little bit accustomed to this comments. So as I told you, I give you the link to an archive in the chat of this station. So if you don't download it, please do it now and unzip it. You will find some file inside. Okay, and you just to open the terminal and start a fresh bash by just typing bash and source the discovery mode file. You will have some instructions and just follow the instruction. It's a little game. Okay, it gives you the opportunity to, in fact, you will have some functions in which, for which you will give a parameter, which is a directory on your drive, and the objective is to fully explore this this directory. So maybe we can have 5 or maybe 10 minutes to let you the time to perform the game. And if you have any questions, feel free to ask me. Sorry. Yes, I can give it to you now. Sorry. Sorry. Here it is. So just to show you up. When you open the links, you should come to my personal cloud. Hope it's the case. Sorry, my computer is a little bit slow. So you can download it. Okay, it's an OCA file. Yep. Then you can open your file exploration. It's usually your whatever you are located. So up. Where is it? It's here. Say. And you will see that you have a few files, in fact, inside of it in the bash directory and scripts here. And these are, in fact, shell scripts that defines few functions that will be useful to perform the web chat. Let's up. Let's go back to our here. So you can go at the place where you downloaded these things. And you just have, once you're in the script here, you can just source it. So it's discovery mode.sh. It gives you the informations. Okay, and the idea here is start the game. So let's say I want to explore. So the command to get a new file, a new directory to explore is parse new dir. So you just choose whatever you want. For example, the course workshop Puma app, and the scripts will get you in the directory you've chosen, and you've got here the number of file that you already discovered and the number of file to discover. Okay, and you can use different command, for example, the ls one to discover new files, and those files implement the counter. And the objective is just to be sure that you find, well, here it's a quite large directory, but find these 72 files. So for that, you should use the ls and the cd commands, and maybe the pwd if you are a little bit lost on where you are on your location. So feel free to exercise this a little bit, just to be sure that you get accustomed to the cd and ls command. One thing that may be useful that I didn't say a little bit earlier, but you can Bash has some kind of auto-completion, and you can use the tab key to complete the path or to complete the command. Okay. So for example, let's go here. if I want to go in the bash directory, I can just start with the B, press the tab path, and the file will be completed via bash. And don't forget to look also for hidden files. So let's take maybe 1 or 2 minutes more and then continue if you don't have any problem with this commands. Okay, so suppose you have all the files, you are fond of the file, and if not, you will be able to launch it again every time you want it. But just quit the bash instance app, because this script defines a lot of stuff that won't be useful for the rest of the presentation. And let's start now to see some other commands, very basic commands also, to modify the tree structure. You will have a very useful command which is called touch, which allows you to create a new empty file. Okay, so you just call it with touch and the path to the file that you want to create. And also for creation, you have the mkdir command for make directory, which allows you to create an empty directory. You have a very useful command, very useful options. The -p. Okay, let's have an example. For let's go here. Okay, suppose I create a new dir, and as you can see, it's empty. And suppose that I want to create a wall tree structure. I can do. If I do without the -p, suppose I want to create /s/b/c, okay, it will give you a warning and an error to say to you that you cannot create this file because when you create a new directory, the a/b should exist before creating the C directory. Under that, you can use the -p, options, which will create the A directory and then the B directory and at last the C directory. Okay, it's very, very useful option. You should get lazy as many times as you can. For we will see command to create new stuff on the hard drive. Now you have the copy commands. Which is cp for copy, which allows you to create some copy of either directories or files. Okay, so you will have to give it the file, the path to the source file and the path to the dest file. Okay, so the behavior of cp depends on what are the type of the file that you are giving. So suppose that rc and destination are files just, and that dest does not exist. then we just create a new file called dest, which is a copy of the src file. You can provide lots of parameters to this function, as to this command. Sorry. But if you do so, then the last parameter should be a directory, and every file that you give here in parameter will be copied in the directory. Use the -r option with the directories to make a recursive copy. So it copies, for example, here. Okay, if I do, then I have a new directory called C. Okay, I should have called him D. Well, it will be maybe easier. And D will contain the same stuff as the A directory. Okay. So the -r is also a very interesting option, and it allows you to handle a copy of directories. And now that we see how to create some stuff, we can see also how to remove some stuff on the tree structure. And you've also, since you have a function to create new directories, you also have functions to remove empty directories, which you'll call rmdir for remove directory, which also have a -p option. And that works a little bit that the -p of its mkdir equivalent. It tries to remove all the empty directories. For example, if I do here rmdir A, since A is not empty, I get an error. So I can use the sorry. Okay. Sorry. Sorry, I should have a look at that, but the rmdir.p should. Okay, I will look at that when you will be in the next workshop. And you also have the IRM commands, which allows you to remove the file. And if the -r option is provided, then you can remove the directory recursively. For example, if I try to remove, I cannot remove directory directly with rm. I should use the recursive option to remove the A directory. Okay, and the last command that you will see for modifying the tree structures is mv, which allows you to move the file in the tree structure or to rename it. Okay, so it has the same syntax as the cp command. Okay, and you can provide either files to the src will be moved into dest. Okay, if dest is a directory, then src will be moved inside the directory dest, and if it's not, it will either overwrite it if the file exists, or just rename the src into dest. Okay, and you can also move lots of files in one time, but here you still have to be sure that the last parameter is its directory, and every file here will be moved into the destination directory. So in the material that I gave you, you also have a file which is build mode. So process in the same way that you did before. So let's say up. You go into the script directory and you source. You source the build mode file. Okay, this time the objective is you will give it a directory with the same kind of command, parse new dir, and you will have to reproduce the tree structure of this directory. So let's have an example. For example, let's start the game with the parse new dir, and I want to create a copy of the build example, which is given to you, and please feel free to use it as an example, and I will create my new in the test directory. So here, what happens? It creates a directory called test. Okay, it gives you the content of the build example directory that you want to copy, and you will have to create the same tree structure inside this directory. Okay, by using the npadir command, the move, cp, touch, and this kind of things. You are provided a command which is compare trees, that gives you the difference between the source directory and the current directory, and to spot what are the difference between what you are trying to do and what you are trying to copy. So I'll let you a few minutes for that. Okay, for example, I can show, we will try to create a tier 1 directory. And if I do the compare tree, you will see that I created the tier 1, which correspond to this tier 1 directory. And you will have to create the same tree structure in as less commands as possible. You don't have to, you shouldn't run them, you should source them. So really use the source and the name of the script. If you run them by using the dot slash, for example, the dot slash syntax, it will create the functions and everything that is needed, but it will be destroyed once the script is done. You're welcome. So let's have still a minute, and then we will go a little bit on because we still have some steps to see, especially the Git commands. And maybe I will need to take the questions part to sure we have time to see everything that we should see today. Okay, so once you're done with the build mode, you can also do it a little bit later if you want to practice. It's still interesting to see how you can do it using the different options of the command that I showed you, and to do it with as few commands as possible. But we'll see. We have lots of stuff to see, so I will continue with a few other comments that may be useful. Okay, the most useful of them. Okay, you have the cat command, which allows you to print the content of the file. If I just, for example, let's say the pass tester one. Okay, it will print here the content of the pass tester file, and I can give lots of files here, and they all be concatenated. But maybe the most useful command ever is the man command, which allows you to access the man page of so the main page is, it's manual page, which gives you everything that you need to know about the commands, a list of the options, some example usually, and you will find lots of other stuff, interesting stuff on that. So now let's have a talk on how commands are executed when you call them in a bash shell. Okay, usually you can just execute some executable by giving just calling its name. For example, if I want to execute the pass tester, okay, I just have to do to name the current file. Okay, please note the / here prefix, which dot is identifying the current directory, and pass tester say I want this file in the current directory. I could also give the full, the absolute path of the script, and it will be executed as such. And what you have to know is that, in fact, commands are usually files. For example, ls is just an executable file. But you can get this the file which is executed by doing the which command. If I do which ls, it gives you that the ls, what it's called when you call ls, is /user/bin/ls. I can do it on every command that we see. And you will see that almost every command that we saw today are in fact executable file located somewhere on your hard drive. But how do we go from the ls command to this user/bin/ls file? In fact, Bash have a way of discovering the commands where based on very important variables, which is called pass, which is an environment variables. What is environment variables? It's just a variable, as in every programming language, that contains information. And in fact, it's a little bit more than just a variable. It's those environment variables defines and monitor and modifies the way Bash runs and the way it behaves. Okay, you have lots of environment variables. You can list all of them with the env command, and you will see that there is lots of them. And every those variables will define the way Bash behaves. And the variable that we will be interested in today is the path variable that you can see here, which in fact contain a list of different directories. All these directories will be searched to find the command that you are typing. When I'm typing ls, okay, and pressing enter to get the list of the file in the current directory, in fact, the bash will search in those directories to see if it finds an executable file called ls. Okay, it will search. The order really matters in this. Sorry, the order matters. It will start with the first directory. If it finds something in that, it launch. The bash executes this file. If it doesn't find it, it will look in the next directory and so on until every directory is searched. So, for example, if let's say I go here, if I want to execute the path part, when I do that, it will search in all these directories here and see if it finds the passport .sh file. Okay, in these directories it does not, okay, because it's not part of any of these directories. But you can modify the way bash behaves by modifying those variables. For example, if I want to be sure that passport will be fine, I can modify the path variable to look at these directories. Okay. What I'm doing now is just adding the directories, git bash intros, bash, the script directories into the path variable. And if I try to launch again the path part, this time I don't have any error. Okay. But what you will see is that modification done in this way are not permanent. If I quit the bash and I start it again, if I try to get passport.sh again, I still have this error message saying that the command is not cannot be found in the path directory, in the path file, path variable. Sorry. So every time you modify the path, every time you launch a bash shell, you will have to set up this variable. But how can we do how can we make this modification permanent? In fact, you will have some files, some very special files. Sorry, it's here. Some very special files that are loaded and executed every time you launch a bash instance. And in fact, it's just some kind of bash scripts. And you can just add at the end of the file these lines, which will modify, in fact, the path variable anytime the bash script is read. Okay, it's very important to know how to do that, because usually when you're installing locally some kind of softwares on your computers and you don't have the root rights, you should modify this variable to be sure that the executable are taken into consideration. So what you can do now, okay, you see you have kind of interesting scripts. You can try to modify the variable in such a way that the path tester command is found. Okay, so you will have to modify the path variable in the first time. In the first time, modify the path variable with the export command directly in the shell, and then make this modification permanent by modifying the bar.fc file. So I let you a few minutes to do that, and if you have any questions, feel free to ask me. So we can do it together. Okay. So the path tester command is in this directory. So what I will do is just export the path variable. Don't forget to add a $path, which takes back the value of the path command. Okay, so you just modify the variable to the directory that contains the path tester file. And now if I launch the path tester, then okay, the file has been found. As I say now, if you want to make this modification permanent, you will have to edit. I will use Vim, but you can use whatever text editor you want, even a graphical one if you want. And you will have to modify the partial.c file. Okay, this file is quite huge. Can be quite huge, okay? And what you have to do is just adding at the end of the file a comment that we're talking about. By doing so, every time I will launch a bash instance, okay, this file will be read and this command will be executed. So you will modify the path variable anytime you launch a new bash instance. Okay, so let's try it. If I quit the bash instance and launch a new one, then the path variable should be modified. And we can test it by just calling the path tester. And you will see that the path tester has been found, even though I didn't change I didn't manually change the path variable. It's just because in this file, the bash rc file, which is a very, very important file, it is read anytime I launch a bash instance. And at the end of the bash script, I just run the command export, which modifies the path variable anytime I launch a bash instance. Is that okay for everybody? Okay, so let's start the. Does anyone has installed Julia on his machine before coming here, or does someone need some backup for the installation? Because at the end of this talk, you should have a running Julia instance, and everything that we show here should allow you to install the Julia on your machine. Okay, so let's say that everyone has a working Julia installation. If not, just feel free to come back to me and to see how we can install it together. And we'll go to the second part of the talk, okay, which is on Git, how to have an introduction on Git. I've been a little bit slow on the first part. Okay. So now that we know we still how to use the basic of the command line, we can dig a little bit into Git's software. So what is Git? Git is in fact a version control system. Okay, it's a system in fact that records files and every modification that are done on these files. Okay. and that it is done over the time. So anytime you need to have different version, you can reverse the modification you did on files. In fact, it's some kind of archiving software. So it stores, Git aims at storing files and also modification on the files and modification over time. So you will have a complete view of what you have done on different files somewhere in your disk. I won't get into why using Git. Okay, it's very useful, and you will see it a little bit later. We have done also, we will do a bit of Git testing. But okay, without getting to why Git is so awesome, we'll see what Git can do for you. So Git is in fact a distributed CS. It's not only on your computer. You have a local of the files that you will track, but those files are also synchronized on the server. Okay, it allows you to make some kind of backup, even though Git is not a backup software. And the idea is that it's a client-server architecture with synchronized files. And all these files can be shared between all the people that works all together on the same project. We will have some kind of work on that. So what we will do? Sorry. So the idea of Git is really to follow some files, follow the modification that are on the file, and also to share this modification with other people that you are working with. And this is done using a client-server architecture. Just to be sure that everything will be okay on this slides, this presentation, sorry, we will use, I will define some kind of vocabulary that I will use during the presentation. And the first one is the repository. Okay, repository is a key concept in Git, and it's only a directory, okay, on your file system, but a directory that in which the changes will be tracked. Okay, it's really the place where Git follows the files and the modification. A Git, you know that a directory is a Git repository if it contains a .git directory. And in this directory, you will find lots of files, configuration files, all this kind of stuff. And it's inside this directory that the Git magic is done. What you can see, it's okay. Here you have an example of a small example of a Git repository. It's a regular directory containing directories and files. Okay, and all these files can be tracked by the Git system. And we will see how we can do that, how we can modify, and how we can share the changes that are done on this kind of directories. So please keep in mind that even though you define a repository, every change that are done in this repository is not automatically tracked. You will have to inform Git that you want to track this file or this modification on the file. Okay, Git does not do this stuff for you, and it's better like that because you can have a complete hand on what you are doing and how you are tracking the modification on your files. So this is called staging. In fact, just telling Git, I want to follow this file, or I want to take this modification into consideration. Once you have tracked some modification and tracked some files, you can commit them. Okay, the commit is just in fact a set of modification or additions to the current repository. The commits are some kind of box in which you will put the different modification and different additions that you made on the Git repository. Those commits are named, and the name of the commit is very, very important. We will see it a little bit later. Okay, when you are doing a commit, Okay, it will look at all the changes and all the addition that you made in the previous commit and put them all together into some box, into a whole new commit. You can see that each commit, in fact, defines a snapshot of the repository. Since it tracks different modification and different files, getting the start, the initial conditions of your repository and all the commits, then at any time you have a complete snapshot of the Git repository. Is that okay for everybody until now? Don't hesitate to ask questions because these concepts are very, very important to well understand the Git system behind that. Okay, so now that we have those key concepts, okay, there are a few of them, but I didn't show all of them. But the three concepts are the core of the Git system. We can have now first touch on the Git Git software and also on the usage of GitHub. So the first thing that you will need to know that you will need to do is to create a GitHub account. If you already have a GitHub account, just log in on the platform, and if you don't, you just have to go on github.com. So I'm already logged in, so I will log out. Okay, it's a little bit slow, but you should come, yes, on this page, and then you can sign up here. Okay, if you just have to sign up, it's a classic sign up on the Git the platform. Please send me in the chat your account name, your name account, because we will use it. We will create a common repository on which we will work all together. We will see in a minute. So if you already have an account, just send me your nickname. And if you don't, create a new account and send me your nickname, please, so we can make the first can go on a bit later. That. Sorry, I have an emergency. I'm coming back in a few seconds. Sorry. Okay, is there anyone that does not have a Git account now and that need times to make the registration? Because I see that I already have lots of nicknames. Okay, please take your time. Okay, fine. So, in on your GitHub account. I'll take a little bit time for me since my PC is awfully slow today. And start a new repo. So do it also on your side because you will have some kind of manipulation on the repo that you just created. So to create a new repo, either you start here with start a new project, or you can also go on the plus in the right upper corner, select new repository. Okay, choose a name for the repository. You can do it public or private. I will do it private for the sake of this presentation. And don't forget to add a README file. You will need it to make all the manipulation after that. And then you just create a new directory.
Guillerme?
Yes.
Maybe just zoom in a bit on your browser too. It's kind of small.
Oh, sorry. Yeah.
Or yeah, maybe F11 to put it full screen and save a bit of space on top.
Sorry?
Yeah, put it also maybe full screen if you want to save a bit of space on the address bar and so on.
Yep. Up. Okay. Oh, I don't remember where I put the F11 key. I guess it's this one. Yes. Okay, so you start. You just come here. Okay, and here you have your new repository. The next step, okay, the step 3 is just to install Git on your machine. So it depends on which operating system you have. I get that most of you, if you're here, you have the Debian-like operating system. And then just install the version which is in the repositories using apt-get install git command. So let's start here. I already have Git installed and I don't use apt-get, but okay. Just to be sure, do someone need to install Git on his machine? So should we wait a little bit, or can we go a little bit further and start the manipulations? Okay, so it seems that Git installed on every machine of anyone. Then we can clone the repository. So you just created a new repository. You would just need its address. Either you take it here or you can go here. So you copy the address of your Git repository, and then you just have to clone it. So to clone, in fact, you will see what it's like. You just call git clone the URL of the repository. Okay, it will ask you for Up. Okay. And you should have now, if I do an ls command, you should have a new directory which is named after your Git repository. Just go inside of it, and you will see that you will have the README file, that appears here. If I look at the content of the README file, here you will see that the README file is initialized with the name of the repository, and if I look up the content of the file, okay, is you can print the content of the file with using cat readme. Okay, so what we've done now using this this command is just in fact get a copy of the directory which was hosted on the GitHub platform and get a local copy to make some modification on that. Okay. So while I'm adding your nicknames to the repository I just created, use your own repository to make some modification. So before doing that, let's have a look at a classical workflow when you work with Git. In fact, you almost always follow the same workflow. First, you will get the left modification, the left distant modification. Then you will perform your local modifications on your own drives to modify the different files and all this kind of stuff. Then stage all this modification, create 1, 2, or many more commits. Okay, retrieve the modifications once again to be sure that you will have all the distant modification. And if you don't have any conflicts, we'll see a little bit later what is it. You can send your modification to the server so that any other people working on the repository can get the modification. So let's have a little closer look on how to get this kind of things. As I said, before modifying your repository, you should be sure that you have the last version of the repository. And to do so, either you create a new repository, what we've done with the Git clone, but you cannot do that anytime you want to make a modification. So we have a command which is called Git Pull, which in fact connects to GitHub or to the Git server and retrieve all the distant modification. These modifications, which are some commits made by other people, are integrated into your local copy of the repository. It will, if you have some conflicts, it will try to solve the conflicts automatically, but sometimes not, and we'll see a little bit later how we can handle this. But for the moment, just consider that Git will integrate all the modification without any problems. Once you get your modification, once you get your copy, you can make your modification. So I let you a little bit of time to create a new Hello World file and edit the README with whatever you want. So as we saw a little bit earlier, to create a new file, we use the touch command, which will create a Hello World file. And let's say I want to edit. So what I've done here, and I invite you to do the same on your machine after having cloning the repository. I just created a new file, a Word, and modified the README file. Okay, if I now do a cat on the file, you will see the modification I just made, just adding some kind of text inside the file. If I go here, even though I'm refreshing, you will see that the modification are not taken into consideration on the server, and we will have to explicitly track the modification and send them to the server. So once you have performed the creation of a new file and edit the README file, you will have to stage the modification. Okay, to have a look on the modification that you've done that are not staged for the moment, you can use the Git Status, which gives you lots of information on the current repository. And the one that are interesting us now is that you will see that some modifications in red are not staged. The first one is that we modify the README file, okay, and this modification has not been staged, and we create, you see here, it's in French, but it's untracked files, and you will see that the hello world file is not tracked by Git. So we will use the git head command to stage the modification, and in the first time we only stage the README notification. How do we do that? It's just using the git add command and giving the modification that we want to stage. By doing that, okay, I just told to Git take the modification I've made on the README file, on the local README file, take them into consideration to be added to the next commit. If I now do the git status command, you will see that this time the modifications are in green. It's say that they are staged, they are tracked, and they are indexed, in fact, and they will be added to the next commit that we will make. Is that okay for anybody now? Don't hesitate to interrupt me to ask questions. As you can see, I cannot see the chat, so if you have questions in the chat, I cannot read them for the moment. But you can just interrupt me to ask me questions. So now that we are done, we need the next step in the workflow is to commit the local modification. So we have told to Git to follow the modification that we made on the README file, and now we have to validate this modification and to create a new commit that we can send to the server. The command is quite obvious. To make a new commit is git commit. Okay, then just git commit will validate all the modifications that we have staged since the last commit. If you call it like that with the just git commit, you will have your text editor that opens, and it will ask you for a validation, modification message. In fact, it will ask you for a name for your commit, and you will have to choose one which is relevant because all these names appear in the Git history, and it's a good way and an easy way for other people you work with to understand in a few words what you have done on these files. So you add a message that will be headed to the commit, save the file and git. And what you will see here is that a new commit with the name add project description has been created. It concerns one file, and we have made a few insertions. Now, if I do a git status, you will see that the modification has disappeared. Why? Because the commit, now the change have been validated. Okay, so the modification on the README file just disappeared because you already validated them. So you can do the same and create a new commit to first stage the hello world file and create a new commit for him using a very useful options for the git commit command, which is the -m, which allows you to give the commit name directly in the command line. So first step, stage the modification. Okay, if I track there, you will see that now the modification are tracked and create. a new commit. Here I used, as I said, the -m options, which allows you to give directly a string after that and to give a name directly in the command line. As you will see, it won't open the editor program, since it will take here for the commit name the string that I gave here. So now we have two local commits, and even though we tracked the modification, if I go back on the Puma workshop, you will see that our modification does not appear on the server. So what we have to do now, and the next step in the workflow, is just to be sure that there is no distant modification. For that, we launch a Git Pull command. And since I'm the only one working on the repository, and since you will be the only one working on your repository, you will see that no distant modification has been done. Then we are ready to send all the commits that we made locally to the server. And to do so, we only need to send the modification, and this is done by using the git push command. The git push command is the reverse of the git pull command. It will push, it will send all the modification to the server. Up. Okay, and now, as you can see, the files and the commit have been sent. So if I go back to the server, refresh the page, here you will see that the hello world that we created and the README that has been changed here. Is that okay for everyone? Okay, if it's the case, I let you do this kind of work here. So you will clone the repository, the same repository at a different location on your drive, and apply the same workflow as before. It means that on the other directory, on the other repository, you will do some local modification. So apply the workflow, which is first get the distant modification, perform the local modification, stage modification, commit them, then and then send them. Okay. Take the time to do that once or maybe twice, and ensure that all the modifications that you have made are shared with the server. And I will use this time to add your nicknames to the repository I just created. J'ai pas fini. J'ai pas fini. Okay, what time is it? Oh, I'm a lot of late. I get that. I would just cover theoretically sorry the configs part, and then it will be over for me. I've been very slow for this presentation. I'm very sorry about that. Okay, so in fact, conflicts can happen when you make a Git pull, and when there are distance modification that are in conflict with the local one that you made. Okay, so when you perform git push, as I said, you will have the distant modification that will be integrated in your local repository and sometimes cause some troubles. When the system cannot resolve the conflict automatically, you will have to do it by yourself. And how you do that, in fact, the workflow is always the same and it's not really hard. You have to find the conflict locations, and you have command for that. You will need to resolve the conflicts, perform a full commit, and then send your modifications. So first, you have to seek the commits. You have command which is called Git Diff, which gives you all the modifications that have been done on the current on your current repositories last commit. And in fact, you have some options like the diff filter, which can show you the unstaged modification since the last commit. And since Git are doing some modification of the files when there is a conflict, you will see the file that appears in the list here. So you just use this command, and you will see a list of files that have untracked unstaged modification, and among them you will have all the files that have ongoing conflicts. You just have to edit them, and you will see that somewhere in these files you have this kind of things. It's always the same. Okay, you will have this token, which show you that in fact you have a conflict here. The first part are the local modification, the one that you made on the file, and the second part are the distance modification, the one that are on the server and that we try to integrate into your local copy. The only thing that you have to do to resolve the conflict is choose the modification that you want to keep and just remove these tokens. Okay, you do that for all the files that are subject to conflicts, and then you just have to perform a full commit, and a full commit is just performed by git commit -a. Okay, once it's done, you just have to push on the server like you've done before, and conflicts are resolved. I'm really sorry I rushed a little bit the end, but if you keep this slide, you should have no problem with dealing with conflict whenever they happen on the Git repository. So it's for me, my presentation is over. Do you have any questions about that? And sorry for the time that I took. Okay, so if you don't have any questions, I'm over with that. And once again, I'm sorry to have been so slow and not to have performed the part on conflict resolving.
Guillerme, can you hear me?
Yes.
Yeah, I just have a question. So did you create a common GitHub repository so everyone can pull it and then add files, and so maybe we can work on this afterwards?
I just need to add the worker on that, but okay. Yes, it's done. It's called Puma Workshop, and you will work on that. You can work on that.
Okay, that's really great. Okay, thanks a lot.